she's setting up. I'll mention that she is the Herbert A. Simon University professor. She's got a cool endowed title, Herb Simon, one of the fathers of AI, very cool. And at Carnegie Mellon, and she is the head of the machine learning department there. And she'll be talking to us about human AI interaction. And she looks like she's about ready. Yeah, she's up.
Okay, thank you very much. So I will explain a little bit about this concept of AI from a perspective of what we call autonomy. So I am going to focus on the aspects that these AI machines are supposed to be able to perceive the world, which is sensing, reasoning about objectives, and eventually actually moving. So this is an example of a robot at Carnegie Mellon navigating in our corridors, this CoBot robot, autonomously, which means that nobody's remote controlling the robot, and basically the robot can decide which force to apply to its motors, which turns to take, when to stop, how to avoid obstacles. So it's completely able to navigate. So in these days in which people are so, and we are all talking about autonomous cars, you have to see that these robots in some sense are what we call autonomous indoor robots. So they don't navigate in our streets, but they are capable of navigating in our indoor environments. So I'll spend a little bit of time just explaining from the point of view of what's in essence here in terms of actually how do they do this, and just to try to explain a little bit about this closing the loop between perception, cognition, and action. So basically these robots and these AI devices are equipped with sensors. And sensors are just devices in robots, cameras, in other elements is like text readers or OCR character readers. You have temperature sensor, it doesn't matter. Something that takes into account what's happening in the world and transforms these into some data that machines can process. So there is this concept of sensing. Our eyes are sensors, and somehow our ears are sensors. So we are able of perceiving the world. So these robots, in particular these CoBot robots is an example, sense the world by having this device that's a laser, which is kind of a laser range scanner. But let's see, given that the topic is a little bit about the limitations, let's see these lasers basically do a swipe of 2D swipe. You can have more sophisticated lasers. You pay much more, and they can have much bigger swipes of the 3D space. But basically, it's kind of a mechanism to build information on where are the obstacles in this world. So they basically tell you at which distance the obstacles are. And the connected depth sensors also does, instead of a 2D swipe in CoBot, it gives you like a 3D view of where the obstacles are. And with this type of information, they can build inside of the computer information that's kind of like the distance to obstacles, or a 3D view of the world in terms of distances. This is what we call a point cloud. So this is what this is cloud. So I'm going to just show you in terms of navigation what happens to this robot. So this is, I just want to emphasize the following. So this is so the robot is equipped with a map of the environment, which are the architectural floor plans of the building. Basically a PDF file that the architects provide, and believe it or not, most of our buildings in the world have PDF files that are the floor plans of the architectural floor plans of the buildings. And if not, the robot can also learn this, but I will not mention, the beautiful thing about these floor plans is that they are the static features of the environment. No chairs, no tables, no plants, no anything, except the things that are what we call long-term features. And the robot uses this kind of long-term features to devise its position. Now here comes a topic that is important for us to understand. Basically, based on its motion and its sensors, robots have, or these devices have uncertainty about their exact position orientation, which is captured here by showing these multiple orange circles, which means that the robot somehow has a little peak of distribution that it must be there, its belief, but it does not know exactly the specific orientation and position in XY location in the building. But the beautiful thing is that as it moves, so this is actually the view of the depth. This is our filter point cloud. Let me just explain this. This robot is only looking for walls, and as such is processing its images to find planar surfaces that can be assigned as walls. And here is the floor, and the different colors show the distance, but the floor is not used for localization purposes, but eventually these walls, as you'll see, there is a certain point here, and I'll stop just for you to notice, in which here, right there, a little bit of the wall was being seen, and at that distance, it was mapped to in the map, that particular part of the wall. So there is this matching algorithm that tries to match what it sees with what the map says it should be. So if I were here, this should be the distance to that wall. If I were here, this should be the distance. And based on what you sense, you revise your belief, and eventually you decrease the uncertainty of where you are. And so the robot, when it sees over there, actually that corner, right now, look at the corner appearing from a sensing point of view, that detection of those two walls at a particular distance identifies and matches perfectly with that corner, and then the robot decreases its uncertainty and knows much better where it is, and basically takes its turns and does all its navigation based on this combination of its own motion with the sensing. So when you see the robot moving around at CMU, that's basically what it does. Humans are perceived, and all these other objects that are not wall are perceived, but they are not used for localization purposes, but for obstacle avoidance in navigation. It does not run over the things that it finds, but it doesn't use them, the dynamic objects, for any navigation. Is that clear? So this is what a robot is. And I'm sure if you would see a robot moving around, you would wonder, how do they move? And now this is it. That's how basically one approach to move is to actually sense and map to some mapping, to some map it has, and tries to see where it is and plans the route accordingly to its destination. So within these particular kind of like navigation purpose, and there is something that I want to emphasize that becomes crucial. A robot, because it actually knows where it is in the building, it knows its XY location in some floor plan, can be used as a mobile data collector. This is a side effect of the fact that the robot localizes well. This robot at CMU gathers data about, for example, Wi-Fi data in every single point of the building, because it now can assign whatever sensor it has on board to capture this external vital of the building, temperature, humidity, noise level, Wi-Fi, pollution, you name it, because the side effect of knowing where it is can assign the value of the sensory data to exact locations in the building. This is something that I really would like also to emphasize, because we tend to think about robots moving around or cars moving around with performing services for people, moving around, carrying people, and so forth. But as a side effect, they actually also can capture a lot of data. So, for example, instead of relying only on the data that humans actually may be able to collect, we can use these robots, these autonomous robots, to have them actively collect data as needed, because they are great machines that actually, in this particular case of mobility, know where they are. And therefore, they can give us data that maybe no one else can give us. So this is just a parenthesis, but this is something really interesting in terms of like being able to use these robots for this type of data collection. So these robots have navigated at CMU, just to finish this navigation part, for more than 1,000 kilometers, currently probably. This was in 2014, 1,000, but maybe now 1,300 kilometers. And they just navigate everywhere in these buildings, in particular also at NYU. I believe this is an NYU building in which we were I was on sabbatical at NYU in the summer and in the whole year, and they navigated there too. So I brought the robots. So what I'm saying is that it is like this concept of just having them go by themselves. Nobody follows these robots. Okay, so this is the first part, but let's just delve a little bit more on this autonomy aspect. The first aspect I would like us to delve on is the limitations that these creatures have. So, for example, they don't understand many of the things they see. Maybe with more deep learning, they'll understand more, but I'll talk about this later. They might not understand what people ask, and they definitely have actuation limitations. Our particular CoBot robot cannot go upstairs, doesn't have legs, and definitely cannot open doors. It doesn't even have hands to open all the doors of the world. So in some sense, there is this kind of realization that these AI machines we produce, be them like the actual robots, or be them like a Siri, or be them like a recommender, are devices that have limitations. There are like contributions that we are making, but they have limitations. So given this, a few years ago, I was very upset because our robots, in some sense, were not able to navigate in the building. How would they go from floor to floor without actually my students helping eventually? So we kind of invented this concept, or this concept that the robots actually ask for help. So these robots move in the building by themselves. We don't follow these robots. Even the other day, I constantly meet them when they are going from place to place, and nobody follows these robots. But when they need help, they ask for help. And it became a feature, the fact that when they actually are not capable of doing something, they just stop and basically ask any human for help. So here is a robot, how they take the elevator at CMU, and they just go to the elevator hall, and basically they just shout up, can you please push the up button and hold the elevator door? It really doesn't matter. It's not targeting, just a second, it's not targeting any specific human. And in fact, it doesn't even know if there is human around. It just screams, It says, it actually speeds, and the synthesizer of the voice tells with one tone. Then we actually, in the second round, we say louder, and then louder, and then poor guy stops. But I'll explain what happens then. But then there is always a generous human that says, yes, I'll be able to help you. And eventually, it doesn't also detect whether it's the elevator on the right or on the left. Us, it's on the right or on the left. Here is Stephanie Rosenthal actually helping. And the robot moves into the elevator by itself. So it doesn't ask a human, push me into the elevator. And then when it enters the elevator, basically it says, okay, I need to go to 8, press that elevator button. Someone does that. When it gets to 8, it says it's at the 8, and the robot goes out. So the interesting thing about this is like this concept that in its own plan, which involves going through this building, taking turns at specific intersections and so forth, there is that thing, which is the elevator, that it cannot do by itself. So basically, it needs help for that much of the whole plan. And that opened, in some sense, this ability to really let them go and be autonomous. So this thing is not capable. Maybe you can tell me like this, oh, Manuela, why don't you do a little arm that press the elevator button? Or why don't we connect with the electronics of the elevator? I can, actually. I have now a little arm. But no matter what, there will be some other limitation that it will have. So it's not about like assuming I cannot do an arm or I cannot like connect with the elevator. It's more like the realization that these AI systems, basically we need to develop them aware of their own limitations. Now you can ask me, what if like nobody presses the elevator button? What if like screams and shouts and nobody helps? Well, guess what? It sends us email. So it's very smart, and after some time, if nobody helps, if nobody really is around, or if there is someone in front of it that doesn't let it go for a while, it just says, come and rescue me. So, and that's it. It just doesn't have any problem, and we actually don't need to interfere with its autonomy, because part of its autonomy is like, okay, I'm stuck. And then if by any chance nobody goes and helps this robot, it basically just sits there, or if it's in the floor where the lab is, it goes back to the lab. I couldn't send the email to the person it was going to make a task. I can't do it. I was stuck there. Nobody came and helped me. Or I was at the elevator. Nobody pressed the elevator button. That's it. And nothing wrong happens because this robot just didn't deliver the book on time, or didn't escort the visitor, or didn't do a task. But the beautiful concept is that, so the thing that fascinates me and that you have to understand is that it's autonomous. It's on its own. It can fail. It can ask for help. But somehow it can do it by itself. Do you understand? So this is like the thing about this AI that I really work on is like how do you kind of deploy these things and let them be independently of always eventually doing it by themselves. So these robots now, from the actuation point of view, they cannot do anything in terms of like becoming better at going up the elevator, because when a person presses the elevator button, the robot doesn't learn anything. I mean, there is no arm, nothing. So it's always incapable of pressing elevator buttons. However, in terms of cognition, if the robot actually does not know something, for example, if someone tells, bring a coffee to the lab, and this robot, you have to understand something. CoBot does not know how to scramble eggs. It does not know who won the last football game. Knows nothing. This robot basically is very kind of narrow, like we talked before. Very well knows very well how to navigate, but basically it's always trying to go, where should I go to pick up the object? Where should I go to drop it? It's really a navigation robot. And basically, that's what it's looked for. So if you tell it like anything you tell, the robot tries to match all the language we say to where should I go? Which object should I pick up? Where should I drop it? So here it says, I don't know what coffee thing. This object is not in my knowledge base. And now, instead of asking the human, where should I get coffee, it actually goes to the web. And the web, which is the thesis of my student Mehdi Samadi, I'm going to search the web to see if this coffee thing, where is it? And this knowledge on the web says this coffee with high probability is in a kitchen or in an office. And it has some color, which, it go to the kitchen. Now, look how beautiful. It now knows everything. I will collect the object coffee and deliver it at the lab. I recognize lab, LAB, from your speech. It had learned that LAB was some kind of room. Is that correct? Is that what you mean? Yes. Okay. I'm done. I'm like, fine. I'm on my own. Don't bother me. I can do it by myself. I was fine until then. Now I can ask you, so how is it going to get coffee at the kitchen? How does it do? It just stops there in the kitchen and just says, hello, could you please put the object coffee in my basket? So there is no limit, there is nothing wrong with just asking for help. And tell me when I'm done. Maybe somebody says, I'm done, thank you. Okay, now I can do it by myself, this transportation. So this, and there it goes. And it goes everywhere and does these for objects, for people, and so forth. But this second part of this asking for help is asking for help when asking where coffee is now fundamentally different from asking to put an object in its basket or from asking for taking the elevator, because it actually learns. It actually learns, and I actually want always to show this. This is the internals of the robot, some kind of symbol, object rounds to coffee 7602, which is the number that the robot knows about the location of the kitchen, and some kind of like how many times, some kind of weight to this knowledge. So what happens internally is that the moment that it actually knows that coffee is in this kitchen, it saves that information. And currently the robot, if you tell it, go to Manuela's office, it knows 8002 or 7002, it knows lab, it knows kitchen, but it was not because people eventually entered all this knowledge but because it acquired it by interaction with humans. It can also acquire whole plants, but I don't have time to explain. We can actually instruct the robot on what to do, but let me just skip this and mention this first part, which is, so I'm exactly at 20 minutes, so I'll spend the last 10 minutes saying about another aspect of this human-AI interaction, but let's first just summarize this first part. So in this kind of human-AI interaction, so the robots plan based on their actions and others' actions. They can actually do this. They can proactively request help, and they learn from these replies. While the humans directly, remotely, because of email or through the web, they can request tasks, they can execute actions for the robot when needed, and they provide requested information. So look at my thesis in some sense, or my point is that what we have to get used to is this collaboration between the human and the AI. And not just that the AI will do it, or just that the humans will do it, and then the AI does, but the humans are part of not this kind of cycle. So this is like the human-AI interaction. Now, one of the last aspects of this human-AI interaction is the following. So an AI system, in particular a robot, does something by itself, and or classifies an image. There's something by itself. So look at your experience or my experience when this robot stops in front of your office. So if the robot stops in front of my office, which stops many times, I mean, I had I will report on the exact number, but at least many hundreds of times it has stopped in my office, constantly stops in my office bringing visitors and so forth. So this machine looks like it does. It's like kind of a metal thing with a camera on top and some beautiful omnidirectional wheels built by Michael Citra. And so you have this thing that you got used to the robot. You know that the robot does things, but questions arise. You would like to be able to actually ask, what are you going to do next? Which path did you take? How did you come up here? I did not follow you. You just arrived. What happened by the elevator? How long did it take to arrive here? Did you successfully escort the visitor later? Why are you late? So in some sense now, all these questions about this autonomy started to arise. And this is the biggest moment in which you understand, I don't want to interact with an AI system that's completely opaque. That's completely opaque. So that started a new kind of focus. Now that they could move, they could localize, they could eventually learn from the web and so forth. Now another aspect of this AI system became important. How do we find out what have they done while they were by themselves? While they were autonomous, whatever they did that I did not have interference on. So that became this goal of trying to explain what they are doing. And first we made some effort on trying to explain through lights, and the robot now actually turns left, shows when is going to turn left and turning right. And also another very interesting thing is that when it escorts a visitor and you follow this robot, the visitors have no clue if my office is like 10 kilometers away or just 1 meter away. They start following the robot completely like, where is it going? And now the robot actually, because the robot knows, the robot actually shows in its kind of column, as it's approaching, this progress bar goes from blue to green, and the people know that they are approaching this thing. And the robot, in some sense, did not use to reveal its state, and now it reveals much more of what it's doing for the human, so this transparency. And also, this thing is trying to find out what happens to the robot. The robots function in another world, and all the AI systems have weights, parameters, they have distances, they have angles, they have all sorts of information that does not match exactly answering the question what happens while the robot is on its own. And it's a long experience. They can go down corridors, they take elevators, they go again around, they do all this kind of navigation, and they see tons of things as they go. So we kind of log all of these, and again, I wanted to show you, this is what the internals of the robot are. This is in some sense, the brains of the robots at some level of abstraction, but they record time, like timestamp 139225071778. What is that? Tuesday at 10 a.m.? Or what is this? August 4th? We don't understand 1392507178, but that's what they know internally. So now it becomes a question of how do we go about translating these to things that humans understand, like locations. How do we know this is like an office? So we have to put semantics, and now we are working on this problem of trying to have the robots generate explanations. So go from that internal kind of like representation to say, I went straight for 15 meters and turned left, then straight for 51 meters and turned left, then straight for 10 meters to reach the destination. At least this is more than giving us the XY coordinates in some space that I don't understand, and we introduced this verbalization space that enables the robots to generate explanations of different level of detail. It can say, I started these, or can say I traveled 26 meters. So basically you have this concept of having the robot explain its own experience. So it becomes this more transparent robot. It cannot explain yet why are you late. This is a thesis of my student Vittorio Pereira that is trying to understand this concept of late. And what is this being late, or other concepts of how many people, was the kitchen crowded? Wow, I don't know, 2 people, is it crowded? And it depends on its experience, all sorts of things. Did you wait a long time for the elevator? All these types of questions that we take for granted require the robot really to analyze its experience and to try to answer these in language. And so finally, we also are able to learn when humans actually say things like, tell me exactly how you got here. That's a point in a verbalization space that the robot actually generates an explanation for. But then if the human says, okay, now only tell me what happened near the room 7004, that means that the explanation needed is of a different nature, more specific, and the robot generates another explanation, and eventually when you say, can you only give me a brief summary, the robot generates another summary. With deep learning, we are able also to now understand the scene. So the robot is capable of looking at the world and trying to say, I should be near the kitchen because I can see a microwave and a sink. So it's eventually these correlations between vision produce additional abilities to explain things, and we are in the process of combining these all with the deep learning sensing to try to make more sense, always with the goal to explain to the humans what happened while it was autonomously doing something. We also have been using a lot of deep learning for scene classification, so the robot knows in which floor it is. So in conclusion, I want us to understand, or at least this is the research that we are doing, and that eventually I will be happy to discuss later, which is this human-AI interaction, in which it's more about understanding how these humans and these AI systems are going to interact in terms of the humans and the web and actual mobile robots. We have a future in which potentially all these things will coexist, and they will eventually be able to coordinate and distribute tasks between them and benefit between each other. And there is this concept of transparency that is now a great value, so that we do not, in fact, interact only with black boxes that just tell you, oh, do this, do that, and without being able to at least question, why am I supposed to do this? Why are you recommending to do that? And therefore, we are doing a lot of research on this. So just as a final thing, I would like just to mention that at Carnegie Mellon, in some sense, one of the things we realize because of these AI is that it's a field of many disciplines. It's an interdisciplinary field. You have to know tons of robotics and machine learning, AI, signal processing, all sorts of human aspects. So we actually created this new entity called the CMU AI, which tries to bridge all these different kind of interests and areas towards eventually solving the larger problem of really having AI and intelligence as part of our human societies. Thank you very much.
So questions for Dr. Veloso? Looks like somebody stepped up to the mic. No? So let me start with a question. And you referenced in about the first 30 of your talk this notion of limitations. So the robots have no arms, they have no fingers, and so there are limitations. And the limitations you're able to overcome because they're able to talk to humans, have humans help, and so forth. Would it be too far of a stretch of the imagination to basically conclude that in order to achieve autonomy, there will always be a limitation? Robots will always be limited, and so maybe you put in an arm, maybe you put in some fingers, maybe you put in hands and so forth, but even if you did that, there will be another limitation. Is it a stretch to say that your belief is that robots will always be limited?
Yes, in some sense I think that humbly, if I look at myself, I have a lot of limitations, and I don't think that there are any humans that don't have limitations themselves. The amount of knowledge that we have around us, it's going to eventually, no machine is going to be able to understand it all the time, given like the complexity of our world. So I do believe that things will, AI machines, robots in particular, will always have some level of limitation. And my approach is, in fact, to embrace the fact that they have limitations and provide them with the ability to actually invoke, give me more data, because I cannot classify this thing as a slug. I cannot. I mean, whatever you gave me, this comes up at zucchini. But I mean, I think it would be interesting to have the machines themselves invoke for this help. And that's what I've been trying to do research on, is to have them proactively ask for help as part of their autonomy. So they will be autonomous, but from time to time they will let us know they can't do it. The same thing with asking, like, which papers talk about something. The machine can say, I mean, I've looked at everything that's on the web, and I don't know how to do this unless you give me more guidance, unless you specify more. So in some sense, I believe it's inevitable that we will always be interacting with machines that will have some level of limitations.
Hey, so thank you for discussing on especially the transparency. Two related questions.
Yes.
One is that from the transparency aspect, can you were there anything that was surprising to you that you cannot diagnose? And the second is, how can you tell that the data that it gave you were not modified, changed, or how can you authenticate that those are real data?
Yeah, do you want to come to CMU to do a PhD with me? So these questions are very, very important. But actually, let me address the second one in particular. So when the robot arrives to my office and I say, where you come from, it tells me a route. And how do I know this is right or not? So what happens now is that in my students, this is Vittorio, we are actually asking redundant questions to see if they are coherent. So we can one day become cryptographers and asking things to see whether they are right. But it's very interesting that if I ask like this, how long did it take you to come to my office? And the thing says, 90 seconds. Then I say, how long did it take you to go to the elevator? And it says 45. And from the elevator to my office, 45. Then the 90 was right. So we are trying to eventually devise mechanisms ourselves to exactly what you were saying, to assess that what the robot is saying is right by asking these multiple questions. And in some sense, this transparency is something that you can always, one way or the other, the data is all recorded, and you can go through this data and eventually do a Python program to check yourself. But it's beautiful to be able, through language, to also validate that the answer is correct, and which we have done, yes.
Very interesting talk, and I'm very fascinated by how you're having the robot collect other data as
Yes.
it moves through the building. So floor plans make a lot of sense to humans, but they may not be the best navigation aid for a robot.
Yeah.
So at some point, are you going to say, see if the robot can navigate by Wi-Fi hotspot sensitivity or something like that? Something that, I guess, a mechanism that a human wouldn't be able to sense or even perceive, but the robot can do very well. So that's my first question.
Very good question. So in fact, the CoBot robots in the beginning were not using floor plans, and they were using Wi-Fi. They still use Wi-Fi if they are in a very large open space, that they don't see walls to actually map. They have a signature of the map of the building, and Wi-Fi is beautiful because Wi-Fi is like GPS. It's a global localization sensor. The only problem is that while with floor plans, we download them from the web, and it's a PDF file, and we transform into a vector map representation automatically. For the Wi-Fi signature of a building, the robot needs to traverse the building, acquiring that Wi-Fi data. As soon as it has the Wi-Fi map of the building, then it navigates beautifully using it. But the acquisition of the Wi-Fi map is more problematic than using the floor plans. But
Okay.
it can use, okay? And we have several papers on showing the two things when one is useful more than the other. Yeah, very good question,
Okay.
yeah.
And my next question is, so far it seems that you're interacting with very cooperative humans. When are you
Yes.
going to introduce nefarious humans that take it to different floors
Yeah.
than where it wanted to go?
So, but I tell you, I mean, they're cooperative, but both faculty and students and everyone at CMU loves to say that to the robot that they are on the 8th floor when they are on the 4th floor. And it happens. The only thing is that, again, this is very robust to the problems with bad answers. So the robot gets out of the 4th floor, and then it realizes it's on the 4th floor, just turns around and says, press the elevator button, I want to go to the 8th. And interestingly, there is always some generous humans, we did not prove this, but there exists a human that presses the right button. And if that's not the case, but it's true, if that's not the case, after some time, again, it has a threshold, and if it had gone up and down, not making progress towards the task, it sends us email. Again, it says, I've been trying desperately to get to the 8th floor, I've got out here, there, and so forth, come and help me. And if not, that's it. But you have to, I just want you to understand one thing. I mean, I really think that people don't realize the feeling of letting it go. I don't care if it stays forever in the elevator. What I want is that it is by itself. And the moment that I was in my office the first time, and the robot went all the way to the lab until the end. I've done a lot of robots, robot soccer, robot these, robot Baxters, manipulators, but you see them always. To get that feeling that the robot disappears from your sight, and then not even you can hear it, and it's gone. I was on the phone always, did it get there already? Is it in the lab? Where is it? Where is it? Let's go and check. It almost had someone to retain me there from not following this robot. And that's really what now for me became common, but it was very hard to just let that thing go by itself. So in some sense, I don't care. The go is what matters. Yes.
One final question?
Yes, so I have a question about, I think, what I would think of as like another part of, or another step of autonomy.
Yes.
It seems like a lot of the research that you're doing with these robots is about them learning. I'm curious
It's about what, sorry?
Is about these robots learning.
Yes, yes.
I'm curious if you have plans to incorporate any sort of them teaching. So, for example, teaching each other without just copying the data set,
Yeah.
or being able to give instructions to someone who comes into your office. How do I get to so-and-so's office?
Very good question. I did not have time to give my talk on learning by instruction, but actually Baxter, I don't have here a picture of Baxter, but we have robots that only perform things because people instructed them. We have what we call instruction graphs. And we tell, for example, this is an example, we say pick up the object and display, grab the object, is it visible, drop, whatever. This was actually instructed. And the beautiful thing about instruction is that you instruct, but then you can also correct. So we are in that loop of instructing and correcting and letting the robot accumulate also lots of instruction. One of my papers is send me an email and I'll be happy to send you a very technical answer to your question in the sense that also they accumulate all these instruction. So next time you might want to know, do they know how to get to the kitchen? Do they have like how to grab these? And you don't even know anymore what you have instructed. So now it becomes not a problem of just instructing, but also recalling that I actually know this. And the paper I'll send you is about this auto-completion. You start instructing something and the robot magically gives you like this. Do you want me to do ta-ta-ta-ta-ta, all these things? And the person says, oh yeah, up to here, that's what I meant. But then after these, do these. It's like this Google auto-completion on search. You can actually auto-complete instruction. And it's really beautiful. And it's a whole other area of interacting with the machine by this instruction. Okay, but please send me email. Thank you very much. Thank you.
Okay,
Thank
please
you.
join me in thanking Professor Veloso. Thank you very much.